In this lab, we're going to try to classify elements as metals, nonmetals, or metalloids based on their properties. And we can observe some of these properties, and we can also test some of these others. So in order to recognize whether something's going to be a metal or a nonmetal or a metalloid, we're going to try and look for which properties show up most on one side or the other. For example, metals tend to be kind of a silver or a gray color. So if you run into an element that has a silvery gray color, it might be a metal. Now that alone is not enough to be able to figure out what the element is, whether it's a metal or a nonmetal, but it's one box you can check off that kind of leans on the side of metals. Okay, metals also tend to be solid. There is one metal on the periodic table that is a liquid at room temperature, and that is mercury. So not all metals are solid, but most of them are. So if you run into an element that is a liquid or a gas, more than likely it's not going to be a metal. Okay, and again, these are tendencies. So just because you're dealing with a solid element or a grayish looking element doesn't necessarily mean it absolutely has to be a metal. But it's kind of some evidence we can lean on to say, oh, this is more likely a metal than something else. Metals also tend to be durable, flexible, and strong. So despite being sturdy, they can also be reshaped in a lot of different ways, which is a very characteristic property that we can lean on. Okay. In science, we can kind of break flexible down into two categories, either malleable, which means you can hammer something into thin sheets, or ductile, which means you can draw things out into thin wires. So if you're looking at a sample of an element that is a thin sheet that still holds its shape when flexed, it doesn't break or snap, or if you're dealing with a sample of an element that is a thin wire that can be wrapped around, it can be twisted and turned without breaking, that's also a good sign that you might be dealing with a metal. Metals also tend to be very dense. Now, there are some metals out there that have a very low density, so things like aluminum and magnesium tend to be fairly light for their size, but most metals tend to be very dense. They tend to feel like they are very heavy based on their size. They have a lot of mass per the amount of volume that they take up. Okay, metals also tend to be good conductors, which means they can transfer heat and electricity very well. In the lab, we're going to be using conductivity testers to test this out, since it would be kind of hard to test for temperature conductivity in this case. So if we can carry an electric current from one place to another, like from a wire to a wire, to use that to light up a light bulb, then that's a good sign that we're dealing with something that can conduct electricity, and metals tend to do that. Okay. If we wind up with something that is magnetic, then it's probably going to be a metal. Now, not every metal is magnetic, not even close. We have like 3 naturally occurring magnetic elements on the periodic table. But all 3 of those elements are metals. So if we run into something that is magnetic, it's probably going to be a metal. Okay. And metals also tend to oxidize or rust or corrode. If you see some stuff on the surface that is like discolored or seems to have a different texture, it's kind of rough, it takes away some of the shininess of the metal, then that's a good sign that you're dealing with a metal. You're dealing with an element that is a metal. Okay. Now, in addition to that, metals also tend to be lustrous. Okay, so aside from being oxidized, typically they tend to have a shininess to them, a luster. So if you have something that has a very nice shiny reflective surface, that could be a sign that you're dealing with a metal. And if you have a metal that is oxidizing, then sometimes it's harder to see that. It kind of dulls the surface. So now metals tend to be what metals aren't. Okay, so we can kind of take this list that we have and start flipping it the other way to talk about some things that make nonmetals very characteristic. Okay, we tend to get more interesting colors with nonmetals, things that aren't just a silver or a gray color. Now, again, that doesn't mean that every nonmetal is bright purple or something like that, but you end up getting a couple different nonmetals that have more interesting colors than just gray. Nonmetals can be solids, but also liquids and gases. So there are quite a few elements that are nonmetals that are gases at room temperature, and at least one that is a liquid at room temperature. So if you run into a liquid or a gas at room temperature and it's not mercury, then you're probably dealing with a nonmetal. Okay, nonmetals also tend to be brittle. They aren't very sturdy. Maybe they might be hard, but upon impact or trying to flex them, they break. Okay, so nonmetals tend to be pretty inflexible. You might find them as a powder or something like that. Okay, so if something fractures when given stress or can't easily be reshaped, that could be a good sign that you're dealing with a nonmetal. Now, it should also again be said, there's always exceptions. You're going to run into some metals that are not as bendable as others, but if you end up with something that's very, very brittle and easily breaks or shatters or powderizes, then you're probably dealing with a nonmetal. Okay, nonmetals tend to have a pretty low density. They're not very dense. Again, could come with exceptions, but most of the time we're dealing with stuff that seems about the right mass for its size or maybe less than that. Okay, and they also tend to be poor conductors. So most of the time we can't move heat and electricity through them very well. A lot of nonmetals can't conduct electricity unless they have very specific circumstances. Okay, nonmetals are not magnetic. There are not any pure elements on the periodic table that are nonmetals and also are magnetic. So if you run into something that is magnetic, it's going to be a metal if it's an element. Okay? And finally, nonmetals tend not to be oxidized. So they don't tend to have this ability to kind of pick up oxygen from the air, which changes and kind of gives a different chemical layer on the outside that has a different texture, a different color, like the rust on the outside coating of iron or something like that. However, they aren't usually as naturally shiny as metals. They don't have as much luster. So the element might kind of have a dull appearance. It might not be as reflective, but that most likely is just from it being a nonmetal, not that it's been oxidized from it. So it can be kind of tough to tell whether something has been oxidized as a metal or whether you're dealing with a nonmetal that just isn't all that shiny. But the more examples you see in the lab, the easier it will get to kind of decide between them. Okay. Now, what if you have a lot of different properties that kind of get split between metals and nonmetals? And it's really hard to pick whether it's actually going to be a metal or it's going to be a nonmetal. Well, you might be dealing with a metalloid. Metalloids tend to be somewhere in between these two lists. So maybe you're dealing with something that is kind of a bluish grayish color. So it's not just straight gray, but bluish grayish. Maybe it is very brittle. It's very inflexible, but it's also a pretty good conductor. Okay, it's not magnetic, but it also doesn't really oxidize either. You might be dealing with a metalloid. Now, there are very few metalloids. On the periodic table, we have about 6 or 7 elements, depending on who you ask, that are classified as metalloids. And again, depending on which periodic table you look at, there might be 6, there might be 7. But there really are not a lot compared to the 118 that have been discovered by the time I've made this video. So in comparison, you aren't going to run into many metalloids. So in this lab, don't be expecting to find a whole bunch everywhere, and you might not lean on the metalloids category too much. Most of the elements on the periodic table are metals. So if you keep coming up with a lot of things that are metallic and have metallic properties, and you keep classifying things as metals over and over again, then you're probably on the right track. Don't second guess yourself. There aren't going to be as many nonmetals, and there are going to be even less metalloids. Okay, so in the lab, you're going to be using observations and tested properties to try and make decisions on whether something is a metal or a nonmetal or a metalloid. And the goal here is not to get things exactly right, but it is to collect data and try to make conclusions about what you find. To test our element samples in the lab, we have a couple tools at our disposal. One of them is a conductivity meter, looks like this. It has 2 prongs on the end that aren't touching each other that would otherwise complete the circuit to turn on this light bulb using the power of this battery. Now, if we can connect these 2 prongs here, these 2 wires, with something that can conduct electricity, the light bulb should turn on. So, for instance, this metal plate here can turn the light bulb on because it's completing the circuit by connecting one wire to the other and allowing electricity to flow. Same thing with this guy here, this oversized penny. Okay, I can get electricity to flow through that too. Okay. We also have magnets that we can use to test for magnetism. Not every metal is magnetic, but if it is magnetic and it's just a pure element, it's going to be a metal, not a non-metal. Okay, like this sheet of aluminum here is not magnetic, but this guy is. So it must contain an element that is magnetic, maybe like iron or something. Okay. Other things you can test just by observation, like you can look at color. A lot of metals are sort of a silvery gray color, like this guy, and like this guy, and like the chain here. A lot of metals tend to be lustrous, which means shiny. That's like one of the best parts of what makes metal ideal for making jewelry. The other thing that makes metal ideal for jewelry is being able to shape it into all kinds of things, like how I can have it flattened out into this here, or I can have it flattened out into this sheet here. We can have it pulled thin into wires, like what I've got here. I can unwind some of this. Okay, so if we can get something, I cut my glove. If we can get something to be flat and thin, like a sheet, like this, we call that malleable. If we can get it into a wire, like with this brass wire here, we call that ductile. Okay, so those are some properties you can look for. Those are both kind of ways to say that your substance is flexible. All right. You can also look for oxidation, which kind of goes against the shininess of something. So when something looks shiny but has kind of a dullness to its surface, or it looks like there's some discoloration there, kind of like how you can see on this copper wire here, this older outside layer compared to this newer stuff that's been kind of covered and hidden away from the oxygen in the air. This oxidation can kind of coat it and cover it, and it's a new compound that has different properties than the metal itself. So metals will a lot of times do this. They'll pick up oxygen from the air and bond, and so you get stuff that may not be as conductive or shiny as the usual metal would be. So that's something to watch out for. That does show that you're probably dealing with a metal, and also can hide some of your characteristics that it is actually a metal. Okay. Some samples in the lab might be kind of hard to test by hand for safety reasons. So like in this case, barium is held in 2 vials, and on the inner vial, it's under mineral oil to keep it away from the oxygen and the water in the air. Okay. There are other samples that are in jars that have lids on them for a reason. So whether it's because the powder can be dangerous to inhale, or it's bad on your fingers, or something like that. Sometimes they're contained, and they're contained for a reason. So don't take things out of the jars unless the jar is already open. Okay, so that means any jars that are open are fair game, as long as you have gloves on. Most of these metals are okay to touch with your bare skin, but there are a couple that are not so much. So we want to minimize contact as much as possible, which is why we're going to be wearing gloves the whole time. Okay, so in the lab, you're going to be looking for properties that are characteristics of metals, or stuff that's not characteristic of metals, which would be like characteristic of nonmetals, or things that are kind of in between, a little bit of column A, a little bit of column B, and might be metalloids. And your ultimate goal is to try and figure out which sample, if each sample is a metal or a non-metal or a metalloid. We're going to try and classify it. Okay. Now you're not going to be scored on whether you get it right or not, so don't stress out too much about it. Just try and do your best to get your observations and data to align with what you pick, a metal or a non-metal or a metalloid.